Hi, I bought a multimeter. This is a brand Honeytek. I don't know this brand. Model is HK48C plus. As you can see, no, you cannot see. This is the model, and this is the model. I bought it to my garage because I don't have a multimeter that measures AC current, only AC voltage there, and sometimes I need to measure AC current. Well, at home I have, for example, this one, which is out of focus slightly probably, but this one is at home. So, well, this will be a short review, and just as a disclaimer, this video is not sponsored. My channel is not popular enough for people to want to pay me for doing those reviews like that, so at least it will be honest. It came with those two probes. There are some isolation caps here. You can remove them. With this K-type thermocouple and with some instruction manual. I will show you the manual in a moment. This is the manual. Now you can see it on the screen. You can pause the video and read it if you like. So let's see what do we have here. What functions do we have here? Let me zoom down a little bit, maybe even more. I can turn it on. And we have hold function, backlight that turns off after some time on itself. Relative measurement, so you can store a value and it measures relative to this value. Min-max function, so minimum value, maximum value of the measurement. You can disable it by holding it. And selection is dependent on the mode. So here you have voltage, DC-AC, millivolts, DC-AC. This is non-contact voltage, and you actually have also live wire detection. But to be absolutely honest, I don't like those digital detectors. This is another digital detector I have. It's crap. Much better feedback is with this phaser. It's called phaser 777. If you need a detector like this, don't bother with this. Just use a phaser. It has a much better feedback. There is an ohmmeter with diode test, with continuity test, capacitance meter, frequency meter, AC/DC, microamps, milliamps, amps, temperature in Fahrenheit or Celsius, and that's it. And well, let's test it by comparing it with this other unit and with my Corad. And I will do, well, I don't have any calibrated voltage sources or current sources or resistors or capacitors, so I can't really do a check of the accuracy test, but I can test it against other meters and do some other tests, and we'll see what happens. And actually, one more thing, it's not an expensive meter, and I don't expect it to be you know, of the very high quality, but I hope for the price I bought it. Now you can see the offer on the screen, because of course I don't remember the price. It was around 60 Polish zlotys, so it's around $15. Well, I don't expect much, but I expect it will be at least somewhat good. So let's do our tests. Okay, sorry for the layout, but I don't have much space here. First we'll see the millivolt range. So let's, they are connected in parallel, just so you see. Let's turn on the Corad, and this is the first interesting thing about the Corad. The output is off, but we can already see some voltage on both meters. And this is just as a reference, as a second meter. Let me set the voltage to, I don't know, to minimum right now, current to current limit, I don't know, doesn't matter really now, but okay, let's turn on the output at 0 volts we are now, and let's increase it, and you will see. I don't know if you can see it well. Maybe it will be better to turn on the backlight, turn on the hold function. It will be off again in a moment, so it doesn't really matter. So, well, I won't tell you what you're seeing because you see what you are seeing, right? Let's turn it to half a volt. This is already already out of range because the range is somewhere to 4 something. So this is the accuracy. Well, I don't know if this is the accuracy of this meter or of this meter or of the Corad, but it doesn't matter. Let's switch to volts and continue. This is switched to volts. This is switched, not yet. This is switched to volts. And let's continue. I don't know how well you can see the screen. Maybe now it will be a little better, hopefully, because the backlight turns off. Okay, so let's continue increasing the voltage. It's 1 volt now. 2 volts. So it seems pretty, I don't know if accurate or just calibrated as well as those other meters. 5 volts. Yeah, it switched the range. Seems it switched. No, it didn't. 10 volts. 15. 20. Well, this is not really, I don't know if the Corad is showing a value that's too large or if those 2 meters are showing a value that's too low. Okay, so, well, this was the voltage test. Now let's do the microamp test. Both are set to microamps. I will set some voltage here, and we will use current source mode. So let's turn it on, and let's increase it. It's right now, well, the Corad shows 1 milliamp, and both meters show. I don't know if you can see it right. 2 milliamps. So what is the actual current? I don't know. Let's increase it. This is already out of range, so let's decrease it. It's 3 milliamps right now, and when they show 3.7. So let's switch to milliamps. We'll turn it off maybe. Yeah, and this is interesting. Even if the output of the Corad is off, they both show some current. I don't know how it works, to be honest. Okay, let's switch to milliamps. Oh, and this is Actually, this is interesting. When I switched this to milliamps, so the resistance of the shunt decreased. This started showing some higher current, but it's probably due to this small, very small voltage on the output of the current. Okay, so now we are in milliamps. 3.71 on both. 10 milliamps, 20, 50, 100. Maybe let's go to 200. And you can see the voltage drop already. This is something I will check separately. Yeah, so it's pretty accurate on this range. Let's switch to amps then. So both meters are switched to amps now. Let me turn it on. 0.3 amps. 1 amp. You can hear the fan in the current. 2 amps. Yeah, it draws much power right now, the current. And actually it shows 1999 because, well, this when it blinks it's the setting, and when it doesn't blink it's the reading of the current. 4 amps, 5 amps for a moment. Yeah, it works. And what if we go lower, 100 milliamps? 50 milliamps, 10 milliamps, still in the amps range. Yeah, it's not bad. Let's go to, I don't know, 3 milliamps. Yeah, something around that. Okay, but I want to check also those wires, so I will see the voltage drop on the wire on this meter. One moment. Okay, right now we have a wire, one of those wires that they provided, and the meter, this meter, and the power supply connected in parallel, and we have a millivolt range here because I want to see the voltage drop on the wire. 5 amps for a moment. You will see a calculation below. Yeah, but it's not bad. It's not bad. And let me also connect 2 wires and this meter. So this will be another test. Okay, now another test. We have this meter in the amps range connected in parallel with the power supply, in parallel with the meter. But the meter is connected straight to the wires. This is a Kelvin connection. Why did I do it this way? Because I don't want to measure voltage drop on those wires. Let's turn it on, 5 amps, and we have 1 volt, around 1 volt voltage drop on everything. So on this wire, and this meter. Well, those wires look cheaper than that, to be honest. So I'm positively surprised. Well, let me show you this useless live wire detection. This is the live wire detection. The black one is disconnected, the red one is connected. Well, it's not live yet. Let's make it live. And nothing happens. this is, well, this is either dangerous or not working. Maybe I should put my hand somewhere here. Yeah, it uses the hand to, it's live all the time. Well, it's not a surprise, it needs some capacitive coupling to some reference, which can be a hand or something like that. So this is something one should be aware of. And let's also test the NCV function. So let me disconnect it. Yeah, well, this will be live in a moment. This is live now. You cannot see what I'm doing. Can you see any use of this? Maybe I will hold it, it will be better. And now let's compare it to the phaser. It's so much better. Calibrate it, turn on the voltage. Calibrate it even better. No, right now. Isn't the feedback better? No live. And it can be used to detect live as well. So this is much better for this use. Well, actually I wanted to show you more. I recorded a longer video with various measurements of AC currents, AC voltages, capacitors, diodes, etc. Well, maybe we can do at least one more test or two more tests. You know, it doesn't make sense because, well, I can show you what this one shows, what that one shows. It's close enough. But let me show you one more thing. It reacts pretty fast, but not very fast. When I see, it doesn't detect momentary touches, momentary shorts, which might be a good thing or a bad thing, depending on who you ask. One more test I might do is actually testing the hertz range and also testing the true RMS. So we can measure some waveforms on the oscilloscope, see them on the oscilloscope, and see the voltage reported by the meter. Yeah, I will just have to arrange it somehow here. Okay, so let's start easy. This is around 50 Hertz. Actually, this was interesting. The voltage dropped when I selected this range. Yeah, but it's some cheap generator, never mind. The oscilloscope isn't actually very... it's 8-bit, right? So the resolution isn't great. But let's start easy with, well, this is a sine wave, 2 volts, around 2 volts. It shows around 2 volts, it's 50 Hertz. Let's maybe lower the frequency a little bit. And so we can see the effect of the capacitor. The capacitor at the input, probably, or just the generator is not holding the voltage. So let's increase the frequency and let's see when it stops. Yeah, I have to switch range, one moment. Okay, so now you can see as I'm increasing the frequency, it still shows 2 volts RMS. I'm increasing it even more, and now it starts to drop. So it starts to drop the voltage, to show the lower voltage when it reaches around 1.5, 1.6, 1.5 kilohertz. When I increase it even more, it stops showing any meaningful value. So it's good up to around 1.5 kilohertz, maybe 2 kilohertz, but it's best to not measure any higher frequencies. Now let's switch to a triangle wave and see what happens. Okay, well, this is not a triangle. This is a triangle. Okay, let's decrease the frequency. So, well, it might be true RMS, actually. It shows, well, the oscilloscope shows 1.76, the meter shows 1.74. And I actually noticed that the millivolt range, well, doesn't really work. But maybe I'm doing something wrong, because it's the same in my other meter. So on the volts range, AC volts, it shows something. Right, I can decrease the voltage. Somewhat. But when I switch to, well, it shows overload. Maybe it detects some, yeah, it will be this. It detects DC bias, because actually, yeah, there is a DC bias at the output of this generator, so it won't work with a DC bias. Well, never mind. And let's test the hertz. Maybe the voltage is too low, or maybe there is a DC bias actually which interferes with that. The hertz range. Okay, so it needs some meaningful voltage here. Yeah, it starts to measure at around 1.6, 1.7 maybe volts, 1.8. And let's go down with the frequency. 7 hertz. 7 hertz. I won't be measuring anything lower, but let's try just to be. But I won't be measuring any frequency anyway, so okay, well, this is the lowest frequency this generator can provide. I'm in the lowest range. Yeah. Let's increase the voltage. 1.8, 2 hertz. Well, it's good. Okay. So now let's jump higher, much higher, maybe even. 3 kilohertz should be around. Yeah, it's around 4 kilohertz on the oscilloscope. 4.46. Even higher. The oscilloscope says 85, and this one also says 85. I just noticed that the light is horrible. Okay, we'll have to live with that. Even higher. But now the output level of this generator is too low for it to register something. I'm decreasing the frequency because the voltage increases then. well, the manual said something about megahertz range. I don't know. Now it starts to lose it, so it has to have 1.8, 1.9 volts to measure correctly. Yeah. Okay, so let's also see the frequency measurement with maybe triangle wave. But the voltage level is too low. No, I can't set it. Yeah, no, but when I increase it, so it starts clipping, it measures correctly. Okay, so well, this measurement is okay. And I also tested milliamp range. It was similar, so it worked regardless of the shape of the waveform. Okay, another test is for the square wave. So we have a square wave here, the frequency. Let's go higher. Let's go even higher. Well, it's not square anymore. But, well, the hertz meter, the frequency meter, shows it correctly. Let's go down, very down. Oh, pulses. It pulses instead of... Oh, it pulses because it's AC coupled. That's why it pulses. Oh, it shows below 1 Hertz. Let's increase the frequency a little bit. I don't see the frequency here because it's too low for the oscilloscope to measure, but it's around 2 Hertz, so I think it's okay. And let's also see the voltage. So the voltage RMS is no, it's too slow for it, and right now it's around, okay, so even around 15 Hertz it shows some voltage, maybe even correctly, or maybe not. And in the millivolt range, no, it doesn't make sense to test it in the millivolt range. So let's increase the frequency and see what happens. The square wave, let's do the AC coupling here. Measure 200 Hertz, 5.4, this one shows 5.3. Higher frequency. Okay, so at 4 kilohertz it doesn't show anything meaningful anymore. So for the square wave the range is around 1.2 kilohertz. Below that maybe even 500 Hertz, to be honest, because it starts to drop even at 1 kilohertz, and here at 4 kilohertz it doesn't show anything meaningful. Yeah, okay, that's it in this video, and thanks for watching.